Okay, so today we are going to do chain rule. It doesn't matter which bubble you put it in, but again, don't put it in the large one because we're saving that for all the trig stuff because there's 6 of those. It'll take up more room. All right, so here's your chain rule. We did product, that's when you multiply functions. We did quotient, that's when you divide functions. Do you remember f of g of x? That's what's called a composite function. Chain rule is for derivatives of composite functions. So I always say it's like one function got hungry and ate another function. People do mix this up with product rule. You're not multiplying them side by side. One function is completely within the other. That's just something that comes from practice, getting used to how that looks. But ddx, that means take a derivative, and it's going to be derivative of f and g. Again, like I said with the other ones, I don't want you to get hung up on the letters f and g, because what if they're m and n? Okay, I want you to call these ones the outside and the inside. What do we call them for product rule? The first one and the second one, and then for quotient, it's the top and the bottom are the numerator and the denominator. Here it's the outside and the inside, okay? So this is the rule. You do the derivative of the outside function, so f prime, you leave the inside function alone. I call that the guts of the problem. It's going to be whatever was in the parentheses, like whatever was inside. And then you chain on, and I usually just put a little multiplication dot, the derivative of that inside stuff. Now, sometimes you can have more links in the chain. Like say you had f of g of h. You would do the derivative of the most outside, leave all the insides alone, then do the derivative of the next most inside one, leave like the truly inside stuff alone. And like, you know what I always compare it to? Did you ever see a cartoon when you were little where like the medium fish eats the smaller fish and then a bigger fish comes by and eats both of those fish, like they're, or those Russian nesting dolls, you know what I'm talking about? So I don't know, I'm trying to think of like examples of ways to like give you an analogy for it. But now we're just going to do a whole bunch of practice. Okay. So looking at this one, the way you know you need chain rule is, do you see how this is to the 5th? But it's not just x to the 5th. It's an entire other function to the 5th. It's stuff to the 5th. Do you see what I'm saying there? Like it's not just x. And again, start all the way over to the side of your paper and maybe write kind of little because you need to have enough room. So the 5th power is the outside function. All the stuff in parentheses is the inside function. This is like the guts of the function. So what you do is we're doing power rule. You bring the 5 down, it's going to drop to a 4, and all that inside stuff stays the same. So just copy it over. So if it was just x to the 5th, you would get 5x to the 4th. It's just we got 5 stuff to the 4th. Are you following me so far? Okay, cool. Times, and then you chain on, so called the chain rule, the derivative of said inside function. So what is the derivative of the stuff in the parentheses? Yep, 6x squared plus 4. Now, believe it or not, that's all one term. And there's nothing that you can do with that. Like, do you get that it's all one thing? Like, yeah, that is all one thing. And so that's it. We're done. Move on to the next one. Now, this one is going to use chain rule. They all are because that's what the lesson is on. But there's actually another rule in there. Because the other rules didn't go away. They're still there. Good. Thank you. Look, do you see how this is the first function? And then this whole thing is the second function? And noticing that is most of the battle. And that's what's going to come through practice. Like, you just have to get the hang of looking at them. Here, bless you. Here's what I'm going to do to set this one up so you don't get lost in the woods with it. Product rule is going to be first times derivative of the second plus second times derivative of the first. I'm just going to put big brackets there. First times derivative of the second plus second times derivative of the first. And I did make some of them bigger than others on purpose. Okay. But you can always set it up blank. I'm a big proponent of set it up blank, like the framework of it, and then just go back and fill it in. So then you have, like, you're just filling in the blanks, right? So the first thing, that's just x to the 4th. Derivative of the second. I'm going to cover this up. take what I just taught you in question 1. We're going to put this derivative in here. Do you see how it's a chain rule? It's not just x to the third, it's stuff to the third. So you would bring the 3 down. It drops to a 2. And what goes in those parentheses? Get 3x plus 1, like the stuff, like the guts of the problem. And then put a little dot for your chain rule. You chain on the derivative of that stuff, which is 3. Good. Okay, that went all right. So where are we in our product rule now? Is first times derivative of the second plus the second thing. Yep, 3x plus 1 cubed, just copy it down, times derivative of the first, 4x to the third. I am going to go further with a few of these because I have seen multiple choice questions where like that won't be the answer. What they do is they factor it. I'm going to use colors here. Do you see how this is all one thing and then you have a plus sign and then this is all another thing? Okay, I want you to look at those 2 terms because there's only 2 terms there. What do they share in common? We're going to do greatest common factors. So what is something that you see they've both got? They both have 3x plus 1s. How many of them can we take? 2. Good. Okay, good. Perfect. I was worried this would be like pulling teeth, but you guys are all with me. That's fantastic. All right. So 3x plus 1 squared, we can take that from both of them. Can we take anything else? You can take some x's. This has 3, this has 4, so we can take, yeah, x to the third. I'm going to put that out front. All right, and then what's left after we remove that? So let's go to the first one, the one I bracketed off green. Let's do the numbers first. You see how there's these 3's in here? 3 times 3 is 9, so we have a 9. Yeah, and then I just wanted to put the coefficient first, and then we have an x, and I think that might actually be it, right? Because we took the 3x plus 1 squared, that's gone. Okay, plus, now we're on to the pink one here. What's left in that one? A 4 is still there. We took the x to the third, so that's gone, but what else? We still have a 3x plus 1. And I'll go ahead and let us stop there. But what you would have to keep going and do for like the final answer to be able to pick A, B, C, or D is, do you see how you could distribute this 4 and then combine like terms? I feel in my heart if I forced you to do it, you could do it. But the factoring is the important part. Okay. That's a lot. It's a lot of algebra. All right. So this is going to be a chain rule because that's the lesson we're doing. What other rule is in this one? Quotient rule. Good. Okay, so again, start all the way over to the side because these get very long. So it's not just x squared, it's stuff squared. You're going to bring the 2 down. It'll drop to a 1, and I highly recommend putting that 1 there because if you don't write it, what happens is people are like, where did it go? All right. And then what goes in those parentheses? That, right? X squared minus 8 over x plus 1. So we did the outside function. We did the squared part. Now we're going to chain on, so put a little dot, the derivative of the inside stuff. So we're done with the squared. Now we're just doing derivative of the inside. This is like the quiz review and the Quizlet you just did. Where does quotient rule start? All right. Denominator. And then times derivative of the numerator. That would be 2x, good, minus x squared minus 8. Derivative of the denominator would just be 1. Again, if you really want to like dig your heels and be like, I'm not writing it, then I guess fine, but you are still learning these. So I feel like you should still put the pattern there. And then it's over. So good, perfect. Okay, I am going to do one more step with this as well. Because what you'll see, like if they give you choices A, B, C, and D, they're going to put all that together. So draw a big old fraction bar. No, just draw a fraction bar. And we're going to kind of decide what goes where. So where would that 2 out front go? That would go on the top. It's really 2 over 1. We've also got an x squared minus 8. And then we've got whatever this is. So we're going to have to distribute and combine like terms. It's like, welcome back to Algebra 1. I'm just going to write it right above. If we distribute, what are we going to get? Yep. 2x squared, good, plus 2x. Here you'd have to distribute a negative. So it would be minus x squared plus 8, good. And then what's going to go together there? Yeah, just be x squared plus 2x plus 8. Good. And then here's like the real point of why they have you put it together. What do you have in the denominator? Because if there's an x plus 1 there and an x plus 1 squared there, it's now cubed. Good. Because you have 1 there and then another 2 of them. Cool. You guys are hanging in. This is good. All right. What rule do I need for this one? Quotient. All right, so it's going to be the denominator times derivative of the numerator, which I want you to write 1 minus the numerator times derivative of the denominator. All right. What is the derivative of square root of just x? But pretend instead of stuff, it's just x. Good. 1 over 2 square root. So watch, it's going to be 1 over 2 square root, but instead of just x, it's that stuff. Okay. So again, that is why I encourage you so much to memorize that one, because it makes your life easier there. Now, if you're like, hey, wait, shouldn't there be something else? Yes, there's a chain rule. You're going to chain on the derivative of 5x plus 1, which would just be 5. Now I ran out of room to put dot 5 at the side, so I'm going to just erase that 1 and put it right here. But that's your chain rule. You have to chain on the derivative of the guts of it, like the inside. All right, and then it's over. Yeah, it would just be 5x plus 1, right? I'm not going to make us do anything with that. But if I did, can you just listen? You would multiply, because we did one like this last time. That's why I'm not going to make you do it again. If you look back in your notes, we did a quotient rule that had a square root in it, and I made you simplify it. It's the same idea. You would multiply the numerator and the denominator by 2 square root of 5x plus 1. If you look back, thank you for heads nodding. If you look back at your notes from last time, we did it. It's just instead of a 5x plus 1, it was just an x. But we already did it, so I'm not going to make you do it again. All right, write an equation. What 2 things do you need? All right, good. Point and slope. Your point is going to be 1 something. How do you get the something? Plug it in. All right, if you plug in 1, that's going to give you 3 times 3 squared. So 27, good. All right, slope comes from the derivative. We will need a chain rule, but what other rule? Product. The 3x is the first function. The 4x minus 1 squared is the second. So again, if you want to set it up, first derivative of the second plus second derivative of the first, you don't have to do that. That's not like a requirement. That's just like Miss Cole's suggestion. Because if you have all the blanks in there, then you can just go fill them in. All right, so first would be 3x. Derivative of the second. This is where chain rule comes in. 2 4x minus 1, which is now to the first. And I highly recommend you write that, because when you don't, if it's gone, everyone goes, wait, what happened to it? And then it confuses them. All right, chain on, like your chain rule dot 4. Oh my gosh, you guys are getting the hang of it. Fantastic. I love it when it's like you're with me and I don't have to pull teeth. All right, plus what goes in the next little blank? Yeah, the second thing. And then times derivative of the first, which would just be 3. And so to get our slope, what are we going to plug in? Thank goodness, right? Thank goodness it's not like a horrible number to plug in. All right, let's see what we get when we plug in 1. This would be 3. What would this be? 2 times 3, which would be 6 times 4 is 24, plus 3 squared is 9 times 3 is 27. let's see, what is 24 times 3? 72 plus 27, 99. To give that some context, if the slope of your tangent line is 99, can you envision what that tangent line would look like? Like almost vertical. Thank you, because that's exactly what I was going to say. All right, just to put it in, visual. And then put it together. Y minus 27 equals 99, x minus 1. Instantaneous rate of change. That means derivative. And then we're going to plug in 4. Maybe go ahead and write them separately so you don't do a linkage error. So this first part, you're going to bring the 3 down. And it's going to be all that stuff to the second. Times, and then you're going to chain on 2. Perfect. Minus, ignore the 12 for a second. What's the derivative of square root? 1 over 2 square root. So it'll just be 12 over 2 square root. Again, that's how it makes your life easy if you just know that one. Now we're going to plug in 4. 4 times 2 is 8, minus 9, negative 1, but squared would be 1 times 3 times 2 is 6, minus, what is that? Square root of 4 is 2, times 2 is 4, 12 divided by 4 is 3, and so your answer to the whole thing is 3. I had check it on the calculator. I just want you to remember how to do a derivative on the calculator. It is math 8. Fantastic.